Hello, and welcome to the online session, the online open day for civil engineering at South Bank University. Now, I'm hoping that everyone watching can hear me. If there's any issues with my sound, just type a message in the live chat. If it's all fine, then no need to type any messages. So, any questions you have, you can always type them in there as well. So today I want to talk to you about civil engineering here at South Bank University and why it's a great place to study civils and why you should consider coming to study civils with us. Start off with an introduction. We'll talk a bit about South Bank University, its history, its mission, its values, and then we'll think about what civil engineering itself is. What does it actually involve? We'll detail our courses, our apprenticeship program, and then there'll be some space and time for any questions, which again you can put into the live chat. So welcome to the online, the virtual South Bank University. The School of the Built Environment, in which civil engineering exists in, is headed up by Professor Chris Harty, who's the Dean. And for you, the prospective student, your Associate Dean of Education and Student Experiences, Alex Pawling. Then there's me. I'm the admissions tutor for civil engineering, and I'm also a senior lecturer in water engineering or hydraulic engineering. My email's there if anyone who's watching this either now or later on when they're recording, you can always get in contact with me directly. As I say, I'm the admissions tutor, so hopefully I'll be able to answer your questions. It's not all about us. In fact, it's mostly about you, the student, and we're very proud of our students and what they go on to become. Last year, one of our students, Alexa, got to the finals for the Women in Property National Student Awards. And so some of our colleagues went along with her to the awards ceremony and dinner. And there's a number of other students that we have had to go to the finals of various different civil engineering or organisations in which we run these kind of competitions. So we're extremely proud of that. Our history, we're one of London's oldest universities, in fact. We were established in 1892. And it sort of came out of being a polytechnic in order to sort of teach kind of practical skills to local students. And that mission kind of stays with us today, even though we're now a very modern former poly, we would call it, one of these sort of new modern universities. That's not only in the design of our buildings, but also in our approaches to teaching and research. We have had actually a lot of investment in our infrastructure and our campus in the last few years. I've been here for about 6 years now, and since I've started, there's been a lot of change. It's a pretty exciting time actually to be at South Bank. The Southwark campus, which is in Southwark and on the South Bank, has had a number of new buildings. The most recent is the refurbishment of the hub, which is this building here you can see in these pictures. And this was opened this academic year. It's a brilliant space. It's also recently been nominated for a architectural award for green refurbishment. So it's been rebuilt from the old sort of 1960s structure using sustainable techniques and sustainable materials. And that's something that we'll talk about in a bit as well, which is very much focused in our civil engineering as well. So in total, we have about 15,000 students from 130 countries, approximately, across 7 schools. And in the built environment architecture, we have about 2,500 students. That includes undergraduate and postgraduate. It's not just about teaching for us, it's also about research and enterprise. And we've got a rich history and performance in research. So our recent Research Excellence Framework, which is the government's national every 8 years, the government kind of tests all the universities in the country on the quality and impact of their research outputs. And we did very well, in particular in civil engineering and built environment. We did very well last year, which improves the amount of central government funding we get for our research. And that, of course, filters down into the student experience as with research-informed teaching. And you will be learning from international experts in these fields. And our vision is to transform lives and communities, and we're extremely proud of our diversity in our student population. And we remain focused and proud of our location in South London, and many of our students come from local, very close to the Southwark area, as well as from all around the world. Our values of the university is with this sort of nomenclature of EPIC, which means excellence, professionalism, integrity, inclusivity, and creativity. So, as I said before, we have 7 schools: the School of Applied Science, Arts, Business, Engineering, Health, and Law. But for today, this is where we, the Civil Engineering Division, is located within the School of the Built Environment and Architecture. That's often students will wonder why aren't you in the School of Engineering? There's a lot of crossover, of course, but as I'll talk to you in a few slides' time, civil engineering really is about the built environment, and it's not about it's about building an environment which works, which is safe, and which is cost effective, and which will last. And these days, it's also extremely important that it's sustainable. So within built environment architecture, we have the divisions, 3 divisions: architecture, civil and building services, which is where civil engineering is, and then construction, property, and surveying. And we've got some nice promotional videos for you to watch, so I'm going to play this one first. Sorry.
The UK is the best place to study in the world, and it felt like a natural choice. I was set to join military as lieutenant, but then decided to change to academia and then civil engineering. It was definitely a right move, and I'm so happy I did it. My family supported my decision to study in the UK financially and morally. I was also given a scholarship, which made a huge difference. My journey to the UK was filled with emotions, uncertainty, happiness, excitement. I had so much support from my university. They had funds for those struggling financially. I'm the residential life ambassador at the university, and it's been an amazing experience. I get to meet so many people from all around the world. I love helping people settle in and organize events to make students feel welcome. To support my studies, I've earned money by doing jobs which I feel will benefit society. I have worked as a security officer at major UK ports, and I've also worked in NHS. I am very invested in charitable works. I started a charity to provide food for people in need back home in Pakistan. So far, we have raised over 1 million rupees. I'm already working to bring this charity to UK. As an initiative, we could lease at home and take this to the homeless community. It means a lot to me to give back to the people in need. My degree is excellent. I focus on the design side of buildings. My research looks at augmented reality in civil engineering. It uses programs to visualize future builds, which save time and money. The career hub team at LSPU has helped me find my dream graduate engineering position. Working at Galco Tri Construction is something I'm very proud of. It's an amazing opportunity. I have created home away from home here. I miss my parents, but some of my friends and family live there, and I love my local community. So, needless to say, I'm happy.
I believe that's the same one, sorry. So, there's an example of one of our STAR International students. That brings me to an explanation of what exactly is civil engineering, which is unlikely for prospective students to have really studied necessarily at school. Civil engineering, as the Institute of Civil Engineers would describe it, is everything that you see around us. It's the built environment. It's the roads, the rail, our buildings, our water supply, our power supply, everything that we take for granted, and we would find very difficult, life very difficult, if we didn't have them, if they weren't working and they weren't maintained. So civil engineering really is vital. For example, we have Associate Professor Hammer Ali, who is an expert in transport engineering, so the design of new smart motorways. So more of my area, which is the hydraulic engineering side of civils, which, for example, is the Thames Barrier, is a good example of a hydraulic structure. A bridge design. So this is one of the first wrought iron bridges, or the first wrought iron bridge, which is over the River Severn in Shropshire, was built in the late 1700s. And still stands. And today we obviously have much more advanced bridges built of much more advanced materials, of composite materials. And this is the Millau Viaduct in France, which is a beautiful bridge. I've been across it myself, designed by Norman Foster. Of course, there's Terminal 5. Lots of our apprentice students work for Heathrow, and the construction of Terminal 5, which was designed by Richard Rogers, the architects. Again, a very impressive building. Often airport terminals are often one of the most impressive constructions in a given nation, because it's usually the first place that people will come into that country. So that, I recently went to the airport in Dubai, which was, in Qatar, which is an incredible building as well. There are also very interesting architecture in London itself, and we're very lucky to be situated in London because we can go on a lot of site visits and we can have a lot of relationships with the with London construction companies and civil engineering companies. This is the Lloyd's building, so the Lloyd's Register building, which is very interesting in itself because all of its sort of building services are on the outside, which is a very interesting and visually striking example. Usually all this piping and service piping would be internally. This is the inside of the exchange. So what kind of construction projects are happening now in London? This is some of the things that our apprenticeship students work on, and also our full-time students will be involved with when they graduate. Obviously, Crossrail has finished, so the now known as the Elizabeth line is effectively complete. It was somewhat delayed, and it was a good 4 billion over budget, so it was not a perfect delivery. And there's a lot of lessons that can be learned in the procurement and the execution of that. But as a civil engineering project, the actual engineering behind it. It's an extremely impressive and exciting project. We currently have the Tideway Tunnel, which is basically the new sewer system for London, which is going to hopefully solve the sewerage problem, which has been a problem in London since Victorian times, because much of our sewage system is Victorian, which is a testament to the engineering skills of the Victorians, that they're still in use, but it's not really fit for purpose in the modern size of London. So the Tideway Tunnel is a very exciting and complex engineering project. Again, a bit like Crossrail, like the Elizabeth line, London is basically a honeycomb underneath the surface of tube lines and pipes and service lines, and in a lot of cases, there's the engineers will come across sort of tube lines and abandoned infrastructure, which is not on any kind of map or schematic. So it's a very interesting and very complex thing, is to dig a tunnel through London. Another interesting project at the moment is the development of Battersea Power Station. And this is a photo taken by one of our colleagues of Battersea, which is Simon Lung, who's an associate professor in structural engineering. So that's the inside as it's been built and constructed. And this is the city skyline of London. So on my cycle to work, I cycle through these buildings. I always say to students when I'm talking about aerodynamics and wind loads on structures that whenever I cycle through the Whitechapel Road past this, I'm always buffeted on my bike. And that's to do with the fluid mechanics and the wind loading and the forcing of the wind through these structures, and it's an important part of our built environment, the completed built environment. You know, is it going to be comfortable for people to walk in? And of course, what are the wind loads on these buildings? South Bank University is, I was trying to look for it earlier. I think it's sort of behind here. So you're very close to all of the action as well. So the university ourselves has got some incredible structures in it. One of the structures, the Keyworth building, has what used to be the largest wooden structure in the city. It's very impressive. The flagship structure at the moment is the Hub, which is what used to be the London Road building. And as I mentioned earlier, this has been shortlisted for an award for green architecture, because the whole structure was refurbished using sustainable techniques and sustainable materials, rather than knocking it down and using lots of new concrete and new steel. And concrete is one of the biggest outputters of CO2. As concrete sets, it gives off a lot of carbon dioxide. And so modern structural design and engineering is very focused on trying to reduce the climate impact and the emission impact of structures. So that means using less concrete, using new types of concrete, some of which is being developed here by some of my colleagues and academics who are using different types of concrete which use recycled materials like recycled glass fibers and other carbon composites within the concrete, as well as with this building trying to use less steel, so reusing the steel. So the actual building itself is a similar, the structure is the same as it was before, but the internal, the inside of the building is completely different and completely refurbished. And it's great because the old building was not particularly pleasant, but this one is an incredible space to work and to work in. One of the interesting things that's been done is the old what we call a waffle slab flooring, which is this kind of set concrete pour which is put into the structure, needed to be reinforced in order to increase the load bearing. And this was done by using carbon fiber. by wrapping carbon fiber tape along the slab. So it's some very clever and novel engineering, civil engineering, and really that's civil engineering is about finding a problem and solving it. And this has come out with an incredible building again, which has been shortlisted for an award. It's a great space for the student as well. The library is extensive. These are now it's sort of a hustle bustle. It's full of books, but this was just before it opened officially. There's lots of spaces in which to do your work and to meet your fellow students to do group work. So civil engineering is not just about designing structures and built environment. It's also about protecting that environment and dealing with natural hazards. And in my particular area of research is coastal hazards. I'm a coastal engineer, which is a branch of civil engineering. And I particularly focus on tsunami. Now, tsunami obviously isn't necessarily an urgent hazard for the UK, but again, this is representative of the breadth of research we do and how it applies. Tsunami also are similar to hazards which would be pertinent to the UK, such as storm surges and sea level rise. And around the UK, we have significant billions of pounds worth of coastal infrastructure, which is protected by seawalls, which will need to be retrofitted because sea levels are rising and storms are getting more severe. So there is a huge need and space for additional coastal engineering within civil engineering. This particular picture shows the aftermath of two defensive structures in the Japanese coast, which were destroyed by the tsunami in 2011. And my research is based on trying to make physical models, small-scale models of tsunamis interacting with the coastline. And we do that because obviously a tsunami is a very rare event and it's a very destructive event. So it's very difficult for us to understand and get data from how a tsunami has damaged a structure. And if we know how a tsunami has damaged a structure, we can design it to be more resilient to that, which is, the modus of the civil engineer. But we can't do that just by looking at what happens in the real world. We need to be able to control and do experiments. And we can do experiments, we can measure the forces, and we can draw graphs, and then we can find equations which predict these forces. So I and my colleagues have done lots of work in a large facilities where we generate small-scale tsunamis and look at the impact on structures. And this is an example of our videos, a video of our experiments looking at the tsunamis interacting with models of coastal structures, and we're going to measure the forces and the velocities of the flow. And this in particular is a video of a tsunami coming past a model of a coastal structure. In this case, we're looking at the sediment transport that occurs. And in particular, this is a process called scour, which is the development of a large hole around the foundations of the structure because of the flooding wave. And if you expose the foundations of a structure, then you will it will lead to failure. So it's a very important aspect. In fact, scour is one of the major causes of bridge failure worldwide and remains a very significant hazard to any hydraulic structure. And that's my area of expertise. And the whole point here is that where civil engineering is not just the design and construction of full scale, it's also the modeling, and be that computational or laboratory physical modeling, of what your design will be and whether it will work. Because you don't want to test it out in the real thing. You want to make sure it's going to work before you build it, because of the money, but also because if it's a structure which is going to be protecting the coastline, for example, then if you get it wrong, it can cause significant losses, both in economic and human life as well. So that's what civil engineering is, and there's more to it than that, of course, but that's kind of the two sides of it. So what do we offer here at South Bank if you came and chose to study with us? Within our school, so within the built environment and architecture, we've got those three divisions: the division of architecture, which is the design of structures, construction, property, and surveying, which includes things like quantity surveying, which is all to do with procurement of materials and making sure projects are on time and on budget, building surveying, etc. And then what we're focused on here today, which is civil engineering, which is also paired with building services engineering. Building services is the things like water, electrics, stuff like that. So, because this is a civil engineering talk, I will talk about that. What we do learn if you did a Bachelor of Engineering in Civil Engineering here at Southbank, we would do a number of core topics. We would give you the fundamentals in order to come out being able to come up with innovative solutions to problems within the built environment, which is what engineering is about. It's about taking a tool and a knowledge and applying it to a scenario that you're not necessarily familiar with. So in order to do that, we need to understand the fundamental physics of what's governing the forces and the loads on our structures. So in doing that, I always say the engineering is applied physics, and the language of physics is the mathematics. So we would study mathematics. We do maths in the first year, and in the second year we study fluid mechanics, which is my module, as well as hydraulics in the second year. But there's also a range of other modules: construction practice, surveying, digital methods such as building information modeling, the mechanics of soils, structural dynamics and structural mechanics, and environmental engineering as well. As in modules, your first year would be focused on these core civil engineering staples: maths, fluids, construction practice, and structural mechanics, so Newtonian mechanics, that kind of thing, materials and geology. And then once you've got through the first year, then we would start studying more in-depth modules and topics, more sort of specialist topics such as hydraulics and advanced mathematics and soil mechanics. In your final year, you do an individual project, which is a very important part of the degree. I'll come to that in a minute. We use a lot of modern software, so you as a student would be able to use, and you would be taught by people who are expert in these different types of software. For me in particular, it's the MATLAB software, which is a high-level programming language, so you can use it for everything, really. Data analysis, big data. And we would teach that in order to give you the tools to for the modern engineering, which is very much data-based as well. There's lots of other software that we use and we would teach you to use as well. So I think that's just a bit of extra information. There are entry requirements. So in terms of A-levels, well, we have, let's start with the courses first. We have a number of different courses within civil engineering. There's the HNC, which is a higher national certificate. And that's what we call a level 4 qualification. Now, if you have A-levels or similar qualifications such as at school, we call that a level 3 qualification. Your GCSE level that's level 2. So you would come into university often with a level 3 qualification. Now, a level 4, the HNC, this is a part-time qualification. It's often very popular with those who are working in civil engineering, and they will have day release to come and study a HNC. They may not have the academic background to go straight into the apprenticeship program, for example. But you could study the HNC for 2 years and then later come back and continue to the BEng, which is a lot of our students in the HNC do that. So that's the level 4 qualification. Then you have the BEng, the Bachelor of Engineering Honours degree, which is the full-time version, which is a full-time study. Excuse me. The requirements for that are BBC at A level, so it's about 112 UCAS points. All of this is on the website, or equivalent BTEC would be DDM. And that is to do the full-time civil engineering honours degree, so you would come out as a Bachelor of Engineering. Now, if you didn't quite have the grades to get in at that point, you could also do the foundation year as well. So you could either do the HNC part-time, do it while you're working and gaining sort of apprenticeship experience, or you can do the foundation year, which has lower entry requirements. Then there's also the part-time and sandwich course, which will allow you to take a year between your second and third year, where you would go and have an industry placement, which is very popular amongst our students. And then finally, the apprenticeship program, which is a 5-year course, and this is extremely popular and it's growing in popularity because what this means is you effectively will apply for a job with a civil engineering company, who then with a government grant will pay for your degree. So it's partially paid by the company, partially paid by the government, and it's a 5-year degree. So it's day release while you're earning a London salary. We have a lot of students doing this, and it's extremely popular. And at the end of this, they come out with a Bachelor of Engineering in civils, as well as 5 years work experience within the company that they were placed. So, what's really important about our degrees is the accreditation. So, accreditation is key for universities to be able to say to a student, here is your certificate, and this is what it means. If you're accredited, that is very clear to all the employers and everybody else what the quality is of this certificate. So accreditation is very important. We have just been reaccredited for 5 years 2 years ago, so which is the maximum amount of reaccreditation you can get. So we're very happy with that. The bodies that do this are sort of grouped together. It includes the Institute of Civil Engineers, the Institute of Structural Engineers, Institute of Highways and Transportation, etc. Now they group together in something called the Joint Board of Moderators, which really prescribe to universities like us what needs to be taught for the modern engineer, for them to say, yes, this is a accredited civil degree. This student is a Bachelor of Engineering. It also means when you come out, you can become a associate member of these institutes, which is a very important step towards becoming chartered. So when you continue your professional development as a civil engineer, you would want to eventually become a chartered engineer. Lots of our my academic colleagues are chartered, which is again is a very specific and advanced level of recognition within the industry of the quality of your work and your skill set. So it's an extremely important part of a future civil engineering career. So we are very good and and understand very well how to get you onto the right track towards chartership as well. Now, I don't want to talk too much about that. I want to sort of focus on the students. One of the flagship modules we do is the group design module, which is always extremely popular. And this really is a final year module, which is quite a significant group undertaking, always very much enjoyed by the students, where they have to design an innovation to a problem set out. And it involves bringing in real-world companies, engineering associates, such as the ones at the bottom of the screen there, to for the students to work with and to present to. So let me just screen this. So this is an example of our students working in these weekly mentoring sessions with these companies or staff from these companies in order to do something which is very relevant to what they might be doing once they are consulting engineers. The students will come up with designs for buildings or structures or different aspects, and it's not just the design of the building. It's, for example, here, which is a new development in Battersea, which has been designed by the students. It doesn't just involve the structural side of things. It involves all sorts of other aspects which need to be put into the design process and presentation, and that includes the drainage, the construction phases, safety, and the emissions and the sustainability. So all of that is very, very important and very much designed to be as it would be if you were doing this as a future employed engineer. There's another one here, which was an airport. So again, these are the sort of the flyers for this, the posters for it, which are meant to attract the attention of the you're behaving as a consultant which has been employed, and you are bidding for a tender. So this is meant to be attractive as a tender. And then you will have to go through the actual design process in detail and in a professional format, again, under the supervision of these companies. Last year's academic year project was to design a retrofit for a viaduct in Brighton, which the idea was to design a new sort of retrofitted residential commercial space underneath these arches, something that's done in London quite a lot. And the students went through the full design process and then had to construct models of their design as well. So it's not only the structural design and the actual structural mechanics, but it's also the materials, the costing, the model. And they came up with some really great ideas. It's really quite wonderful to see. So here are some examples of the finalists. So there's an element of a friendly competition to this as well. So these are the finalists and their designs. And here's some more images of the students working with these companies and with our staff to iron out the problems and present their designs as if they were presenting to tender their ideas, for example, here. And so constructing their designs. We also have very good relationships with industry and former students as well, and we have them come in to give us sort of CPD courses and give us guest lectures all the time. We also, let me just skip that one. This is a really nice animation which was made by one of the groups of their design for this project, which is very impressive. They've used sort of a digital model to present how their design would look once constructed. And again, this is a really important part of being a civil engineer, is being able to convince somebody that you should buy your tender, you should win that project. And this is the quality of the work that our students come out with, which is as good as you would have expect from an actual consultancy work, I think. Some very happy students there. So it's not just about the group design project. We have some very good facilities here. We have the structures lab, in which there are a number of structural engineering laboratory equipment. So we can, in your first year, for example, you will learn how to pour concrete with rebar, how to insert the rebar into the concrete and mix the concrete. You'll learn about the material strength of that and its pros and cons, and you'll do some stress testing on it with strain gauges and a Instron machine, which we have a very large one of. In fact, our structural testing machine is so large that we often do some consultancy for other universities and companies on their designs and their materials. We also will teach you surveying, which is a very important part of it as well. Again, with the latest GPS equipment, which is what you would expect to use in the real world. We would do laboratory work, like I said before, in testing concrete and materials, testing the stress and the cracking, how different mixing of concrete, different compositions of concrete are good for different types of structure. Here, the students, undergraduates, testing aluminium beams for strength and compression and tension forces. We do some fire testing, particularly in the aftermath of Grenfell. We've done quite a bit of research on new types of fire-resistant cladding. One of our favourite, certainly my favourite part of the first year is the geology field trip. This is one of the things that I am the module leader for as well. My background is as a geologist as well, so with the civil engineering, everything we build with is made of rock and materials which come from the earth. So geology really underpins a lot of what we do. We build with the earth and we build on the earth. So we need to know what we're building on, how stable it is, what's its strength, and we need to know what we're building with. So it's a very important part of it. But it's a great trip down to Weymouth in Devon. It's a beautiful part of the world. It's known as the Jurassic Coast. It's a residential trip. The students always have a great time. And it really happens in the first year. And really, the friends that you make on that trip are often lifelong friends. Right. There's some more photos of that. We go to places like Durdledore with the famous arch, and we look at the strata in the rock. We do some field measurements. Another really nice activity that you can get involved in is the Constructionarium, which is where you can go away for a residential week to build a prototype structure. So from scratch, from the design. So in this one, I believe they're building a transmission tower replica. So it's been forged, and it has to be, the foundations have been made. It's all been done by the students. And it's always a really great opportunity to, for your CV, but also to just put all the things that you're learning into practice on a larger scale than we can do in the labs. And again, it's a great residential field course. So socially, it's also a really great event and activity. Okay. Another thing that we do a lot of, we're very fortunate to be in London. There's always plenty of jobs in civil engineering, and there's plenty of opportunities to see sites at their various different stages, the groundwork stage, or at the foundation stage, or the sort of during the first fits and the second fits. And our sort of industry liaison, Simon Leung, who's brilliant at organising these trips. Almost every week, you could go on these trips. He has some great contacts in the industry, and you get some really interesting behind-the-scenes look at these projects and hands-on experience. So there's some more photos of these trips that you can go on, site visits. These are they're all free and they're voluntary. You don't have to go on. You just you'll be given a choice, and you can go on as many or as few as you like, or just the ones that interest you. Let's keep going. The computer's going a bit slow. This is an example where the students went to Heathrow Airport, so you get to see parts of the airport that you may never have the chance to see. Again, lots of our apprenticeships work for Heathrow, so therein we were able to get a behind-the-scenes tour. And this was an educational tour to the Sky Garden, which is on top of the walkie-talkie building, which is a really nice activity as well. And some more site visits. So this is Northcliffe House, which again looks like it's going through the construction phases. And this is actually the hub. So there's some photos of the hub as that was being constructed. Some more visits to buildings under construction in London. And again, so you get a tour with one of the senior engineers on site to discuss, how they're innovating, how they're designing these structures, how they're meeting their targets. So it's a really brilliant opportunity. So there's a few more here as well. This is a wooden structure, the Pavilion in Hyde Park. Some more structures here. So this looks like some groundworks where you've got the steel piles have been driven into the groundworks. These cross braces here are very interesting. So you often see these in groundworks in London and in cities, and they're basically there to keep the walls from collapsing in. So when you dig a big hole, you've got all the weight of the other built environment around you suddenly is not supported. So you've got all this tendency for all of that to collapse inward. So you need to put some sheet piling down to stop that from happening, and then you need to have these cross bases to prevent it as well, to provide a resistance to that. You can see here there is some rebar here ready for the pour of the foundation of the concrete. So that's some really good stuff there. Some more site visits. Right. A quick word on the apprenticeship. We are one of the leading universities in apprenticeships in the country. Again, we are very lucky to be in London and have really great relationships with London-based companies and companies in the surrounding regions. The university has about 3,000 apprentices across the schools, and we have around 700 in civil and building services engineering. Our apprentices are amongst our best students. I really enjoy teaching them. They're very driven, they're very mature, and they're clearly really excited about civil engineering, and really happy to be doing this. The apprenticeship is led in civils by Carlos and Simon, and then in building services engineering as well. And with the apprenticeship, it's not just about learning the technical side of things. It's also about your continued professional development. So this is why you come out with all the tools and the portfolio that you might need to then relatively quickly graduate to become a chartered engineer. And this is where the endpoint assessment and portfolio comes in. And so we have a team of staff that work with apprenticeships to make sure that the whole process is going well. We have a separate building for the apprenticeship team as well, and to make sure that you are developing your portfolio and meeting the requirements of the apprenticeship program. So if you're not aware of what it is, it's basically sort of 20% of it, an apprenticeship, is formal off-the-job training, which is when you come into the university, so that'll be 1 day a week. And the other 4 is practical experience in a real work environment for which you are paid for. So this is they are effectively full-time jobs which you are paid an appropriate salary for. So often these salaries are around 22,000, something like that. I mean, it does depend on your company. You come out with a university qualification, so a Bachelor of Engineering, and all of that employment experience and those technical skills and those behavioral skills and a very rich and significant additions to your CV. And again, you have the endpoint assessment, which gives you this Institute of Civil Engineers or engineering technician or that route into chartership, which is really important. There's a bit of the timetable there. I don't think I will go into that with you. We have a good demographic of students, in particular in the apprenticeship. We have quite a significant number of female students and students from Black and minority ethnic backgrounds. Particularly in our full-time courses, we have a very wide range of student background. We're extremely proud of our diversity, and we see it as a huge advantage. Another example of one of our star apprenticeships from last year, I was very proud to see her graduate last month, is Georgia, who's done really well, and she's been awarded Apprenticeship of the Year. Another one, Ella, with the year before, she was the Apprenticeship of the Year as well. She's a brilliant student, and I think more recently she's won another award. Yes, so the Women in Construction. So she's the best young woman engineer in the country, which is fantastic, extremely wonderful achievement. It's not just those two. We also have Vicky Baith as well, who has won the Apprenticeship of the Year. She was a finalist for the Institute of Highways and Transportation as well. Kimaya too was shortlisted for engineering and manufacturing, and Zainab as well has been featured quite heavily in her company doing the high-speed rail and the tunnel boring for that. So if you're interested, this is mainly for the apprenticeship. If you're interested in that, you can apply through the website. If you're interested in the full-time degree, then you apply also through the website or through UCAS. Right, I think I'm basically coming to the end. A quick brief on the campus. I know I've only got about 5 minutes left. So, as you know, we're right in the heart of South London. It's a great place to be. And this is the campus itself. It's actually quite a small campus. Of course, space in London is a premium. We have some other campus. We have a campus at Havering as well, but civil engineering is entirely in this campus at Southwark. Very close to Elephant and Castle and Southwark Station, and Blackfriars as well. So this is the hub, that new building, which was refurbished. So this is what it looks like again. But this is the hub, the library, for example, which is here in use. Which is a lovely building, and there's lots of space within the library in these rooms where you can book a room using the app. We have a really nice app for the university, which everything, you're logging into lectures, everything is done through this app on your phone. So if you want to do some group work with your students or find a space in the university, you can book a room in advance using the app. And we also have the Keyworth Centre, which I mentioned before, is this wooden structure, which was the largest wooden structure or the tallest wooden structure in London. I think it's been superseded recently, but you can see the wood there. I mean, it looks like it's glass here, but the actual structural members, so the loaded part of the structure is the wooden part. We're at the Student Centre as well, which is in Borough Road, which is also a very nice space as well. And then finally, the most boring part is who we are. Well, we're not that boring, but we're the ones who make you do the work. So we have quite a lot of staff. Well, I say we have a lot of staff compared to some other universities. We're quite small in that aspect, and the advantage of that is that you will be able to access us as academics much easier than you might do at a university with several thousand. Let's say Manchester, where they have 100 lecturers and maybe over 1,000 first year students in civil engineering. Here we have about 15 in civil engineering, and we have about 80 students. So it's much easier and a much more kind of personal and community feel to this university. I think I've enjoyed work. I've worked at other universities in my time, and I really enjoy working here for that reason. Everyone kind of helps each other. There's no competition here. So there I am, just there.